Hello, everyone. Welcome to day 2 of our journey together at the Miramar Fraud Detection with Data Science Bootcamp. My name is Williams, and I will guide you today. Today's theme is building your analytical arsenal. This means learning how to clean, prepare, and explore data, and then use anomaly detection to catch fraud even when we don't know what to look for. Now, in simple terms, we are sharpening our tools today so that no matter where you go or what data you meet, you can smell fraud from afar. So today is going to be about, first, what is called data collection and cleaning. We have a data here which have also been uploaded for you. So when we talk about data collection, think of it like buying yam from the market. You don't cook it with the sand and peels. You have to clean it first, right? So look at this data set as the yam you buy. That you're buying yam from the market simply means the yam is data, the market is the location, what we call data source, where the data is gotten from or acquired from. So today's session is first going to be about data collection and cleaning. Today's session is also going to be about what is called feature engineering. So I said first, data collection and cleaning. Secondly, feature engineering. Now, when we talk about feature engineering, it's all about we turning ordinary data into intelligent insights. When you want to prepare stew, you say you need tomatoes, you need pepper. You know what you then have to do? You have to turn your tomatoes and your pepper into stew, right? That is exactly what feature engineering is all about. So maybe you are here, you're getting to hear about some of these terms for the first time. Please, you don't have to be confused. This is all very important for you to ensure that you have a concrete understanding on all this. In day 1, yesterday, we opened the doors to fraud detection. With a high-level view, we looked into what fraud is. We looked into why it matters and how data science is the sword and shield in this battle. But like I said, in day 2 today, we are going into the engine room. So today is where you begin building your analytical arsenal. The tools, the mindset, the habits that will make you not just fraud watchers, but fraud stoppers. Whether you are a manager trying to protect your company, or you're in this meeting and you're an auditor trying to ask smarter questions, or maybe you're a consultant building systems for clients, or a tech newbie with big dreams. Today is going to be your day 0 moments, the start of understanding the power of data from the inside out. Now, we are going to be working with this real-world inspired data sets. I call it Fincher transactions data. So if you open the case study file, you will see what we have here. Fincher, a strategic case study on microtransaction fraud detection. Every transaction tells a story. Your job here is to uncover the one no one else sees. Presented by Miramar Institute, Fraud Detection with Data Science, Day 2. So welcome to FinShop, where your task is to support the internal fraud analytics team. The company has given you access to 1,500 anonymized transactions, and your job today is to first clean and transform the data set to make it machine learning ready. Engineer new features that can capture fraudulent behavior. Apply anomaly detection techniques to identify potential unknown fraud. So we will be working with this FinShop transactions data. 1,500. In our case study today, you will work with a data set from a fictional African microfinance startup named FinShop. FinShop provides mobile-based microloans and payment services to urban and peri-urban customers. Due to the low barrier of entry and mobile-first model, FinShop experiences frequent attempts of micro-fraud fraudsters, exploiting small transaction windows, testing stolen credentials, or abusing geographic loopholes. You are to download the CSV dataset, which is also in Excel format, from the link sent to you. And you are to access the dataset. That's the name for the dataset. The tools to be used are Python, Pandas, Scikit-learn, Matplotlib library. The goal, like I said, is to first prepare the data, engineer features, detect anomalies. So this is the file name, this is the rows, this is the columns, this is the column name, these are the descriptions for each of them. Now, I want you to imagine this. Imagine this is your organization's transaction logs. And what that simply means is that it includes who made what transaction. That's where we have the customer ID. It also includes what time. That's why we have timestamp in column D. It also includes how much. That's why we have amount in column C. It also includes what device. That's why we have device type in column E. It also includes what location. That's why we have the location zip in column F. And it also includes other behavioral signals, like channel is fraud and all of that, transaction ID and all of that. So for me, this is your fuel, and our job is to refine it into intelligence. Now, let me be very clear. Fraud does not shout, it whispers, and it hides in plain sight, always inside messy, noisy data. So we must learn to clean it just like drinking water. When your water is clean, no dirt, no stone. We must understand our data like a village elder. You know those village elders, those elders we have in the village, in your community. They knows everyone's story, right? They can narrate story from history. They can take you to flashback mode and all of that. So we must also learn this as engineer. Engineers is just like a carpenter. Give a carpenter a wood, you find out the carpenter will turn the wood into a fine furniture. You must learn it like a hawk. When a hawk wants to catch a movement, it does not matter if it's from afar. Hawk catches movements even from far. So our mission today is simple. So I want us to pay attention as we use this 1,500 row data sets. Trust me, I won't just teach you how to code. I will teach you how to think also, because if you must excel within this very domain, then you must also be able to think. Being able to think is very important. Now, taking us back to what I said earlier, I shared with us about some key elements which we must understand for us to be able to perfect this for the two. So let's go back and look at this again. If you have not taken this down, data collection, feature engineering, please take it down. So I've talked about data collection and cleaning. And like I said before, it is very important step you must take. Data is the new oil, but just like crude oil, raw data is messy and useless until it's refined. For those of you that are ladies, imagine you are preparing jollof rice. The rice first is raw rice. And when it is raw, there may be possibility that there is stone inside. The tomatoes you want to use to prepare the jollof rice are not blended. The pepper is still fresh. The meat you want to use needs seasoning, is it not? That's how raw data looks in real life. Now, in fraud detection, we get raw data from bank logs. Bank logs is just who paid, what, and when. In fraud detection, we get raw data from user profiles. By user profiles, I'm talking about name, I'm talking about age, I'm talking about account type, anything that has to give you information about the user. In fraud detection, we get raw data from behavior. By behavior, we are talking about login times, devices used. So when you see type of device used here, it has to do with the behavior. So it's one of those places where we get our raw data from, as far as fraud detection is concerned. In fraud detection, we get raw data from credit history. Are they loan sharks or salary earners? And so on. So, but before we cook this data, we must clean it, we must transform it, we must understand it. That's what I was talking about as data collection and cleaning. In fact, we call this data preprocessing. So don't forget this today. I told us about clean water. And the opposite of clean water is dirty water. Dirty water can kill. Dirty data can destroy your model. So for every raw data we work with in fraud detection, there are some common problems we take note of. The first common problem is missing values. Missing values. Missing values is just like someone forgetting to write their name in a form. Imagine you gave a form to some group of persons and they forgot to write their name inside that form. That's missing values. So it's a common problem in our raw data here, in fraud detection. Another common problem is wrong values. Let's say someone is supposed to enter 50 million. Instead of entering 50 million, this was what was entered as 50 million. Now count the zeros. Are they up to 50? This 3 and this 3. That's 5 million. Wrong values. Another common problem is duplicates. Duplicates is just like same person, same transaction, repeated. So why do we now have to clean this? The reason is because we build models here, and models are like babies. If you feed your babies with the wrong food, they will misbehave, right? That's how it happens here. Models are like babies. The reason why we clean data is because our models are like babies. If you feed them wrong information, they misbehave. Imagine you feed in 5 million as 50 million. Your model will misbehave. Another reason why we clean data is because clean data equals accurate fraud detection. So once these have been achieved, feature engineering becomes the next task you have to carry out. It is where you add sense to your data. Raw data. Let's say our raw data, we have a transaction equals 50,000 naira. These are our raw data. Please flow with me. Feature engineering, what we'll say feature engineered, is now going to be 50,000 naira at 2:30 a.m. outside, I mean Nigeria, so but let's say outside Nigeria, after 3 days of no activity. So your raw data was 50,000 naira. That's how it came. But with feature engineering, which has to do with adding sense to your data, it means when it is featured engineered, this same raw data, you have now added sense to it. It now has meaning. Rather than just leaving it 50,000 naira, look at the extra information that gives more meaning, more sense to it. That this money was actually deposited at 2:30 a.m. Location, outside Nigeria. After 3 days of no activity. That means that account, there have been no activity before that money dropped in. So this gives you context, right? That's intelligence. So in the time you hear about feature engineering, it is where you add sense to your data. Now there are some common features for fraud, which you also need to take note of. One of the common features for fraud is what we call frequency. Now by frequency, we are talking about something like how often do they buy airtime? Think about if it's customers who buys airtime. How often do they buy airtime? The second feature for fraud is geolocation. Now by geolocation, we are talking about the location. Maybe last week, Lagos, now Ukraine. These are some features of fraud. How can someone do a transaction in Lagos last week? So the next transaction, we find that the person is, the location have changed to Ukraine. Another common feature for fraud is time-based patterns. Time-based patterns like, why buy 5 TVs in 5 minutes? How possible? Time-based patterns. You're buying, find out a particular customer bought 5 TVs in 5 minutes. Ratios is another common feature for fraud. Ratios. Ratios like expensive test versus routine check. This one is majorly related to healthcare fraud. So, my dear colleagues, I want you all to think like EFCC. What behavior looks off? They always go with that. You see people spray money, like in Nigeria now, you know, if you spray money and you've seen or you've found or caught maybe a video, EFCC will come for you. Talking about the Nigerian Naira. So once you have understood this, we can now talk about anomaly detection. Anomaly detection is just something off, strange, suspicious. So whenever you are in that situation, you just have this feeling something is looking somehow suspicious here. Something is strange. Something is off. That's an anomaly. It's like seeing 10 million naira transfer from a salary account on a Sunday night. 10 million naira transfer. You saw a 10 million naira transfer from a salary account on a Sunday night. That seems off, right? Suspicious. So we use anomaly detection first when we don't know all the fraud patterns yet. I shared with you some common fraud patterns like frequency, geolocation, time-based patterns, ratios. So sometimes you may not know all the patterns. There are many patterns. So when you don't know it, what we do is anomaly detection. We use anomaly detection not only when we don't know all the fraud patterns yet, but also when we want to catch new types of fraud, not just old styles. We use anomaly detection when we want our system to be smart and proactive. Now, once this is also done, we then look into isolation forex. This for me is the hero algorithm of today's session, isolation forex. If you ask me, I will tell you, if it's easier to isolate, it's likely an anomaly. The reason why isolation forex model works here is because first, fraud is rare, just like bushmeat. You know, bushmeat is rare, right? So what isolation forex does for us, it creates random paths and also sees which points are easily separated. So the more isolated you are, more likely you are a fraud. At this juncture, we will now walk step by step through loading our data, which we have over here. We'll also walk step by step through cleaning our data. We'll also walk step by step through engineering features. We'll also walk step by step through running isolation forex, anomaly detection, and visualizing the fraud. So let's get started. So the first thing you're going to do is to go download Python, install it. Like I told you, you can use Anaconda Okay, you can use Anaconda to do that. So join me. So come over here, open Anaconda, then launch Jupyter Notebook. So how do you do it once your Anaconda is open? Scroll down, look for Jupyter Notebook, look at it here. Click on launch, launch. So if you've started launching it, patience. Okay, so once you click on it, check closely, you will see, get this message saying pick an app. Okay, pick an app. So you can choose Microsoft Edge, then you click on always, if that's the one you want to use from time to time. Then you wait for it to load and open up. So it brings you here. Okay, so I will close this on my right and come over here. This is just the cloud. I don't need it, so I will close this also. Okay, so the first thing I'm going to do is to come over here, upload. I'll click on that upload option here. This is the upload option where I just highlighted, I circled red. Can you see it? So I'll go and upload the file. Okay, so let's go straight up to look for it. That should be um so let's just quickly check. Okay, that's Finshaw. So we'll go back here, upload. I think that should be on my desktop, Finshaw. Oh. So just make sure you check where you saved yours. Okay, so I think I have to save this. Upload, desktop, Finshaw transactions, day two. Can you see it? Finshaw transactions, day two. So I'll come down, click on it. Okay, so once you have uploaded, scroll down and ensure that it is here. You can see it. Finshaw transactions, day two. So once you have done that, come back here. You'll see we have new. Click on the new option. Then choose Python. So you're going to notice it takes you to a new page over here. So the first thing we are going to do is to import the tools we are going to be using. So the first tool we use is Pandas. And the reason for that is because Pandas is a tool, a library, a tool that helps us to read and clean data. Just like Excel. Those of you who know Excel, Microsoft Excel. Pandas is just like Excel, but it is for Python. So I'll come, I'll write, I'll say import pandas as PD. Import another tool. This one is called NumPy. Now NumPy is a tool or a library in Python that handles numbers, anything that has to do with numbers. So I will say import numpy as NP. Now, we made mention of isolation forest, which is our fraud detector, right? So I'm also going to import isolation forest. But for that, I will say from sklearn.assemble import isolation forest. Also, we are going to import another tool. Remember, we talked about visualizing the fraud. So for visualizing the fraud, we are going to import a tool we use for plotting graphs. So for this one, we're going to import matplot library and Seaborn. So we'll say import .lib.pyplots as plt. Import Seaborn as. Now, let's run this. So to run this is what we'll do. Come up here, you will see this run. So we'll use that. Okay. So the next thing we are going to do is to load the data sets we have. So we'll come over here and load that data set. So we'll say df equals pd.read underscore CSV because it's CSV format. Bracket close, bracket open. Now we'll go and copy it, the link for it. This is it here. Look at it below. So come here, right click on the file and choose copy paths. And you see the option copy paths. So right click on it, choose copy paths. Then we'll come back over here. Inside these brackets, we are going to paste it. Can you see it? For the first we ran, I think there is an error. Correct this here. Typo error. It's not pipeline, it's pipe plot. The Y, change it to T. So that's why you can see we have this interpreter. So this is one good thing about Python, gives you the interpreter. So you can run this back again here. Sorry. Okay. So make sure you correct that. So we have just copied the file name, which we want to load. So the next thing we'll do is to come down. We'll say df for data frame dot head. Now, this dot head may be looking confusing to you, especially if you are new to this. The dot head is what shows us the first 5 rows, like preview in Excel. So let's say we are running this. We are told that the feature transactions day 2 is not defined. So why do we have this challenge? So come back here, insert your double quotation, and then go again. Okay, so these are some little things you might miss. Before now, there was no double quotation, and there was also no double quotation. So make sure you enter that just in case you're working. And like I told us, we have a preview. We are saying show us the first 5. We use dot head. So this the data we have just brought in. So everything is here. It's just a preview. Now it's time to clean this data. To clean this data, we'll come down, say df equals df dot drop underscore. What are those common problems I made mention of? I talked about duplicates, right? And others. So if there is anyone we should focus on more, is duplicates. Okay. So let's say we are cleaning this data, we are dealing on the duplicate issues, right? So what do? We say drop underscore duplicates. Our pair brackets will come down df equals df dot what? Drop now. We execute. Now, what this does for us, it's going to remove repeated rows. That's rows with identity repeated. It's also going to remove rows with missing information. You know, we talked about missing values. It's also going to do that for us. NA, NaN, not a number. So once these have been achieved, we can now move to feature engineering, adding sense to the data. In our data sets, we're given the hours, right? We're given the hours, that's timestamp and all of that. So what we are going to do now is to extract the hour they transacted. Is it midnight fraud? Things like that. Feature engineering. So we'll say df, put our square brackets. We're not told if it's midnight. Look at, we're only given the time, 14, 18, and so on. But we're not told if it's midnight fraud and all of that. And remember, if it's fraud, it's been decoded with 1. If it is not fraud, 0, right? So now let's go back. So we'll say hour equals PD dot to underscore date time. Bracket open df. Square bracket, your quote, timestamp. Your square bracket dot dt dot hour. Again, df, your square bracket, amount underscore log. Your square bracket equals np dot log. Bracket open df, the square bracket, your quotes, transaction amount, the square bracket plus 1, bracket close. Now, what are we doing here? We are extracting the hour they transacted. All these customers want to know which hour did they transact. Is the hour they transacted we're trying to what? Extract, sir. Extract, man. I hope we are following. Hour they transacted. At the same time, in line 2 here, we are taking log of amount. It's just like saying in maths, big money is compressed, right? For better maths. Good. So feature engineering. The next thing we'll do now is to execute this. We have another interpreted message here we have to look at, and it has to do with was never closed. So you now go back and look for that very place. You need to provide that bracket that was never closed, and this is the place here. So most times due to speed, you may forget to add some things. The Python interpreter guides you. So you have to come here and provide a brackets. See where I circled. Good. Beautiful. So if we go again, you see that the interpreter will say that code is fixed. Okay, so let's run that. Okay. So let's check again. We have another error message here. It says transaction amounts, key error. So let's look at that. Transaction amounts. So amounts. So instead of that, use amounts. So go back here, use amounts for the name. So remove the name of the data sets which I added there. So just go with transaction amounts and also run this. Let's say we'll have, remember this is a workshop, so I believe you're also doing it live. Okay, so now let's go straight up. This is a model, so we have our model, isolation forex. So say model equals isolation forex. Bracket open, contamination equals 0.01, bracket close. DF, the square bracket, anomaly, the square brackets, equals model dot fits underscore predict. Bracket open, DF, the square bracket, amounts underscore log. Hour are featured, amount log from our featured, you understand? Double square bracket, bracket close. Now let me explain this. This model, what we have just done here, this code tells the model that 1% of data is fraud. That's why you see me wrote contamination equal to 0.01. It's telling the model that 1% of the data is fraud. The fit predict here trains the model and give us labels. It trains the model and gives us labels. The labels can be 1 for normal, -1 for suspicious. So our consign is the suspicious ones, right? Remember what we talked about anomaly. You suspect something is different and all of that. Awesome. So let's run this. Now, it's time to visualize the suspicious ones. To do that, we'll use our tool Seaborn, sns.scatterplots. Bracket open, data equals df, comma, x equals our engineered feature which we added to make sense, our, comma, then y equals amount log, amount underscore log, comma, u equals quotes anomaly, comma, palette. So we're trying to set up the scatter plots equals square brackets. Let's use red. And also let's use green. For the title, plt.title, bracket open, fraud, detection. using isolation forest. Bracket close. So this is going to give us a graph. So check again. Always do your check and balance, cross check, because we don't expect the interpreter to give you an error message. So, okay. So the interpreter didn't give us an error message, which means our code is correct, right? So look at the code again here. Fraud detection using. Can you see why I said do your check and balance? Look at the using. I spelled my own. Haha. I spelled my own using. Oh my goodness. And you can see it's happening. Yeah, you can see what's happening here. Using. So let's go back to that. So change it to using. And I will rerun it. So let's scroll down. Okay, you can see it's corrected now. All right. So you can see that this is a graph, right? So the graph shows us where the outliers means potential frauds. It shows us where they live. Anywhere you see green, as I can see green, it means those places, they are safe. But where you see red, they are the suspects. All these red are the suspects. They are all the suspects. The red are the suspects. So you ask me, sir, I'm an accountant. Maybe you're an accountant and you're telling me, sir, I'm an accountant. How does this help me as a professional accountant? And I will tell you that as an accountant, it helps you know which transactions to flag before audit. Or maybe you're an auditor. It helps you know which transaction to flag before audit. Or maybe you're asking again, sir, as a consultant, how does this help me? This helps you to design smart fraud detection strategies. Maybe you're a manager and you're like, sir, I'm a manager. How does this help me? This helps you as a manager to lead with data that are backed with policies. Are you a tech beginner and you're asking, sir, how does this help me? This is your entry to AI. This is your entry to automation. So please, you don't just detect fraud, you defend your company's future. By learning this today, you're building an analytical arsenal that not only solves problems, but prevents them. You are learning to think ahead. You're learning to create data-powered decisions and to lead innovation in any space you find yourself. In our next class, we'll continue from here. Look at the tree. Thank you.